Welcome to this Maths Made Easy video on sequences. To start with, let's take a look at the nth term and recurrence relation. Now, one way to define a sequence is with an nth term rule. This is a formula in terms of n, and the sequence is generated by setting n equal to 1, n equal to 2, n equal to 3, and so on. So for example here, let's say we've got the nth term, 4n minus 3. Okay. Now this defines a sequence 1, 5, 9, 13, and so on. Okay, and the reason for that is because if we set n equal to 1 here, so if n equals 1, we get 4 times 1 minus 3. Okay, so that gives us 4 minus 3, giving us 1. So that gives us our first term there. And again, if we set n equal to 2 here, if we set n equal to 2, we do 4 times 2 minus the 3 again here, and that gives us 8 minus 3, giving us 5 there. Okay, and like we can see, we get the second term, and we can keep going with this process here. And again, let's just demonstrate one more time here. If n equals 3, then we do 4 times 3, and we minus 3 here. Okay, so 4 times 3 gives us 12, minus the 3, giving us 9 here. Okay, and like we can see, we could extend that sequence there again and again and again, just by substituting different values of n in. Now, a recurrence relation instead defines the next term using the previous one. So first we define un as the nth term, then the sequence is defined by a formula in terms of un minus 1. Okay, so let's take a look at another example. So using the same sequence here, this has the recurrence relation of un equals un minus 1 plus 4 there. Okay. It's important to note here that a recurrence relation alone is not enough to specify a sequence. So for example here, using this recurrence relation here, this could define this sequence here, 1, 5, 9, 13, and so on. But it could also define 1000, 1004, 1008, 1012, and so on. Okay, so it's important to see here that this could also define any other sequence that goes up by 4 each time. So to uniquely define a sequence, we need to specify a term. So for example, u1 equals 1 there. Okay, so that gives us our first term there, and then we can easily just use our recurrence relation to define that sequence. Okay, so that gives us everything we need there for the nth term and recurrence relation. Moving on now to take a look at arithmetic and geometric progressions. Now, an arithmetic progression is a sequence that is created by adding the same amount each time. The first term of the sequence is called a, and the amount we add is the difference d. Okay, so the sequence here for an arithmetic progression, so we just know that this is an arithmetic progression here. Well, this would be a. Our next term would be a plus d. Our next one would be a plus 2 lots of d. So like we can see here, all we simply do is we add d to each term here. Okay, so that would be a plus 3d, and then so on and so on. Okay, we can define our nth term here as un equals a plus n minus 1d. Okay, now for a geometric progression, so if we just note this here, this is for a geometric progression. This is a sequence that is created by multiplying the same amount each time. Again here, we note the first term is a, and the amount we multiply by we call r. This is the common ratio. And the sequence here would be a, our next term would be ar, our next term after this would be ar squared, after that would be ar cubed. And notice at each point here, all we're simply doing is times in by r. So in that case, our nth term here, un, is simply going to be ar to the n minus 1 there. Okay, so that gives us everything we need there for arithmetic and geometric progressions. And finally, let's take a look now at the properties of sequences. So we can have 3 types of sequences here. Let's change the pen colour here just to highlight these different sequences. So we could start with here an increasing sequence. And for an increasing sequence, we can mathematically define this here as un is larger than u n minus 1. So for example here, the third term in the sequence must be larger than the second term. Okay, so u3 must be larger than u2, for example. Okay. Again, let's highlight this with a different colour. The next type of sequence that we can have here is a decreasing sequence. So a decreasing sequence. And again, mathematically defining this sequence here, what we're saying is that un must be less than un minus 1. Okay, so in that case, using this example again, u3 must be less than u2 there. Okay, and finally, our last type of sequence here, if we represent this in green, is what we call a periodic sequence. So a periodic sequence. Now this is a sequence that repeats in a cycle. A sequence that repeats in a cycle. Okay, so this is a sequence here, that repeats in a cycle. Now, it's important to note here that the number of terms in the cycle is the order of the sequence. Okay, but that gives us everything we need there for the properties of sequences, and that concludes this Maths Made Easy video on sequences.